starting with how a signal is processed by the system, we should know certain basic types of signal. So we'll start with the simplest signal. In this signal, I have drawn time on the x-axis and the amplitude on the y-axis. What I have shown here is a signal that is having a value 1 from minus t to t. This is the graphical representation of the signal. I am naming the signal as f of t. This signal can also have a mathematical form that is given in the form of equation, and the equation for this signal would be, the signal has a value 1 between minus t to t. So f of t is equal to 1 for time duration t to minus t, and otherwise the value of the signal is 0. So it is 0 otherwise. The second commonly known signal could be a signal which is like now here also I am taking time on the x-axis and the amplitude on the y-axis. The maximum amplitude that signal takes is 1. So here it will be 1. This is minus t here. This point here is t. What we can see here is this signal is consisting of two lines, and those two lines have got different slopes. This was a signal that had a constant amplitude throughout this duration, but for this signal the amplitude is changing. For this kind of a signal, we can give the equation of the line as y is equal to mx plus c, where m is the slope of the line and it is given as this. Let's consider the name of the signal to be f2t. For writing this equation mathematically, we need to find out the slope of this line and the slope of this line. Let m1 be the slope of this line and let m2 slope of this line. So here it is m2. To find out m1, we need two coordinates, and those two coordinates will be this coordinate and this coordinates. The coordinates of this point will be then, it will be minus t comma 0, and the coordinates of this point would be 0 comma 1. Considering this to be the second point and this to be the first point, m1 will be equal to y2 minus y1. So it is y2 minus y1 divided by x2 minus x1. So here it will be x2 minus x1. y2 value is 1, so it is 1 minus 0 divided by 0 minus t. So this will be n equal to 1 by t. Similarly, we can find out m2 between this point and this point. The value of m2 will then come out to be equal to minus 1 by t. So to write down the equation of these lines, we have m1 as equal to 1 by t and this m2 is equal to minus 1 by t. The noticeable thing here is this is an increasing slope, therefore the slope is coming out to be positive 1 by t. This is a slope that is decreasing slope, that is why it is coming out to be with a negative sign. The equation of f2t will be then, f2t is written using this equation, where at the place of m we are substituting the slope. So the slope is 1 by t from minus t to 0, and the slope is minus 1 by t from 0 to t, and at the place of x we are writing it as t because it is a t-axis that we are considering on the x-axis, plus c. Now c is a value when the x-axis is equal to 0. So we can see here when x is equal to 0 or when t is equal to 0, the value here is 1. So that is why plus 1 in both the equations. And other than this duration, the value of this signal is 0. So it is 0 otherwise. The next set of signals are exponential signals, and there are two types of exponential signals: increasing exponential signal and decreasing exponential signal. power at, and decreasing exponential function is written as e raised to the power minus at, where a is a positive integer. If I roughly draw the shape of increasing and decreasing exponential function, it will be to verify why am I plotting this shape for e raised to the power at and this shape for e raised to the power minus at, what we can do is we can substitute for different values of e, a and t and can cross check. So I'll show this to you using an example. Here I'm taking a is equal to 2, and as we all know, exponential means 2.713. So let's start the calculation from this point where t is equal to 0. So when t is equal to 0, substituting all this in the equation e raised to the power at, we get it as 2.713 to the power 2, because a value is 2 multiplied with 0. So this will give us 2.713 to the power 0, which is then equal to 1. So at this point, the value of the function will be 1. When you talk about the positive time axis, at the positive time axis, I am taking here a sample with t is equal to 1. Substituting all the values of e, a and t, we get it as 2.713 to the power 2. And as t value keeps increasing from 1, 2, 3, 4 and so on, the value of the exponential function or the power of the will also keep increasing. So that would mean a signal that is growing in its value. When you look at the negative time axis, here I am taking a sample with t is equal to minus 1. By substituting the values, I am getting exponential to the power something that is negative. So this will give me a value that is lesser than 1, and as time decreases on the negative axis, the function value also will keep decreasing because it will be 2.713 to the power a large negative value. To verify the shape of this function, we can take the similar kind of values and substitute in the equation e raised to the power minus 8, and that would verify the shape of this waveform. The next signals are the signals very much known to us, sine and cosine waveforms. These are the waveform of sine and cosine signals. The only difference between sine signal and cosine signal is cosine signal is sine signal only, but with a phase difference of 90 degrees. The other important point regarding these waveforms is the zero crossover. Zero crossover would mean when the value of the waveform is 0 or the amplitude of the waveform is 0. This is happening when the waveform is going from positive value to a negative value, so at this point, and also when the waveform is going from a negative value to a positive value, look at this point. So for a sine waveform, the zero crossover occurs at every k pi, where k is an integer. When you look at this waveform, this is going from positive value to a negative value at this point, which is pi by 2. Then again it is going from negative value to a positive value, so it is giving a zero crossover. So for a cosine waveform, the zero crossovers occur at 2k plus 1 multiplied with pi by 2. For every odd multiple of pi by 2, there would be a zero crossover for a cosine waveform. In context to the subject signals in systems, there are certain more important signals. The first one out of them could be a unit step signal. Now unit means 1 and step means to take a left. So this is a signal that takes a step at t is equal to 0 of amplitude 1. This is how the unit step signal is plotted as a graph. This signal is taking a step at t is equal to 0 and the step is of magnitude 1, therefore it is a unit step signal. It is denoted by the symbol u of t. The mathematical equation for u of t is, it will have a value 1 for t greater than equal to 0 and a value 0 for t less than 0. The next important signal is an impulse. Now impulse means a reaction at a particular instant. Similarly, this impulse signal is a signal that will show a reaction or that will show some amplitude at t is equal to 0. The impulse signal is denoted with a symbol delta t. So delta t is for the impulse signal, and the mathematical equation is given as the value of this impulse signal is not equal to 0 for t is equal to 0. That means the value of the signal at t is equal to 0, where it is showing an impulse, is undefined, and the value of the signal is 0 for t not equal to 0. That means wherever t is not equal to 0, that means at this place and at this place, the value of this signal is 0. The important property that is related to the impulse signal is the integration of this signal over the complete time duration is equal to 1. So this is the important relation. The next important signal is a ramp signal. Ramp means an inclined surface. So for this signal, the inclination starts with t is equal to 0 and the inclination is towards the positive time axis. The shape of the waveform is as this signal is denoted with r of t, and this signal has a value which is equal to the time value. So that means when time is equal to 0, r of t is 0 at this point. When t is equal to 1, r of t is equal to 1. That means when this amplitude here is 1, this will also be 1. When t is equal to 2, r of t is also equal to 2, and so on. That means for time 2, this value is also 2. So this signal is given mathematically as r of t equal to t for time greater than equal to 0. That would mean when time t is equal to 0, the value is 0. When time t is equal to 1, the value is 1, and so on. And this is equal to 0 for t less than 0.